So this video is all about how to draw a graph in science. I have collected some data. I've got two different types of glass vessel. I've got a measuring cylinder and a round bottom flask, and I've filled them up with water. I've gone up in increments of 50 cubic centimeters each time, and I've measured the height of the water. It's better to say 50 cubic centimeters than 50 centimeters cubed because it avoids ambiguity. Okay, so I'm going to record my volume on the x-axis, which is the one that goes along the bottom of the page, and I'm going to record my height of water on the y-axis, which is the one that goes up the side. So when choosing my scale, I need to consider the range of my values, which here is 550, and the number of large squares that I've got on my graph paper. So I already know that I've got 9 squares along on my graph paper. So I need to choose to go up in either 1s, 2s or 5s, or multiples of 10 of those. If I choose something like 25s, that's going to be really difficult to plot my points when I come to put them on the graph. So I'm going to need to go up in 100s in order to fit this on the graph. So I would normally just do it by trial and error, to be perfectly honest with you, because if I'm looking at that range of results, I'm not going to get up to 550 if I go up in 1s, right? If I go up in 50s, I might consider that, so I might go, okay, 0, 50, 100, 150, 200, 250, 300, 350, 400, 450. So I can only get up to 450 if I go up in 50s. So then the next convenient number to go up in is 100s. So I'm going to make a tiny little mark down here. It's called a tick mark, and I'm going to put a 0, and I'm just going to make tick marks on all of the thicker lines which show the big boxes up to there. So I'm going to go up in 100s, 100, 200, 300, 400, 500, 600, and I need a label for that axis, which is volume in cubic centimeters. Okay, and then I need to have a scale for my y-axis as well. So my height, I need to start at 0. I can't do a broken scale on this one because you can see that the gaps between the values are fairly even. So I can't do a broken scale, so I need to go from 0 to 274. So, okay, I mean, I'm definitely not going to be able to go up in 1s, right? Or 2s or 5s to get up to 274. What if I go up in 10s? Let's try 10s. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 100, 110, 120, 130, 140, 150. So I can only get up to 150 if I go up in 10s. So let's try 20s really quickly. 20, 40, 60, 80, 100. Just in case I lose my place, make a little mark. 20, 40, 60, 80, 200. 20, 40, 60, 80. So that'll be 280. So that gives me enough space, right? I only need 274. I can get up to 280. That's perfect. So let's go up in 20. So 0 on the bottom. And then I'm going to make my tick marks again. So the thicker lines are every 10 tiny squares. You can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? 10 tiny squares, you get a slightly thicker line on your graph paper, and every 5 tiny squares you get another thicker line, but it's fainter. All right, so anyway, 20, I'm going to do my tick marks first. So your tick marks need to be small and neat. They do need to be there. Your scale is like a ruler, right? On a ruler, you've got the same amount, the same value between each mark and the same distance. So 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240, that's a bit messy, 250, 260, 280, and we need a label, height in millimeters. So this is how my scale is like a ruler, right? My ruler has tick marks at every major interval. So in this case, the ruler is going up in 10. So every 10, we've got a big tick mark, and every 5, we've got a smaller tick mark, and every 1, we've got a tiny tick mark. Same as on the graph paper, right? We've done our big tick marks for every 100 in this case, and the graph paper itself has a slightly thicker line for every 5, and it's got a marking for every 1. Okay, so you've got the same value between each of these intervals. 100 goes up by 100 every time, and you've got the same distance as well. You're going up by 10 tiny squares each time. All right. So the other way to think about this is the value of the big square and the value of the small square. So on the x-axis, the value of a big square is 100, right? This is worth 100 cubic centimeters. So each tiny square being a tenth of that, 100 divided by 10, each tiny square must be worth 10 cubic centimeters, right? That's going to help us when we're plotting. We need to do a line for this one as well. It's fiddly, but it's worth it. So in an exam, you will usually be given a little square of graph paper on the exam paper that's the exact right size for you to use, usually. You don't get that in real life because you just get an A4 sheet of graph paper and you have to work with it. So it's kind of good in a way that on the exam they give you an extra clue. Right, now plotting the points on. So I've got my volume in the left-hand column, and I've got my height of my measuring cylinder in the right-hand column. So I'm gonna come down here. My first reading is 0, 0, that's easy. That's what we call the origin. So I've got a reading there. Now 50 is halfway between 1 and 100, or it's the first thick line, and it's 25, so we need to find 25 on this axis, so we're going to go to 20, and okay, we're going up in 20s on this axis, so we need to think how much each tiny square is worth. So if 10 tiny squares is worth 20, divide that by 10, each individual square is worth 2. So we can go 20, 2, 4, 4.5 to get to 25, or we could just probably do that by eye. Okay, 100, we need 50, so that's halfway between 40 and 60. 150, that's 78. So the easiest way to do this, if we get on the 150 line, we go up to 80 and then come down to, that's 78, right? 115, 110, yeah, 135, 130, 2, 4, 5, 160, that's the easy one, up there. 190, easy one again. 220. You notice I don't go all the way back down to the x-axis every time, because I know with these readings I'm just going along one half box or 5 tiny squares. Right, where was I? 220, 246, 240, 246, 246, and 274. So there's 260, 270, 272, 274. Okay, so now my next step is I need to have a look at those points, and I need to think about whether that is a straight line or a curve. Now, I think I can see fairly clearly that that's a straight line, but sometimes it's not obvious. So yeah, you can change angles, see if that helps you. And you can get a ruler involved. So I can see that my points are basically arranged along a straight line, right? So if I line up with the origin, because I know that that is 0, 0, no water, 0 volume, 0 height, that's fine. And then I'm going to adjust my ruler slightly until I've got roughly the same number of points on either side of the ruler. And then I'm going to, using a pencil, draw a straight line along that ruler. Okay, it doesn't need to be super heavy, and it should be in pencil so that you can rub it out if you made a mistake. It's very, very easy to make a mistake when you're doing lines of best fit. Okay, so I'm going to add a little label to my graph to say that that line is the measure, spelled correctly, measuring cylinder, because I've got 2 sets of results to put on here. So the second set is my round bottom flask. So again, we've got 0, 0, I don't need to make an extra point for that. 50 cubic centimetres, we just had a height of 10 millimetres, and then we're 23, 30, oops, need to be accurate. In the exam, they'll give you the benefit of the doubt of half a square. So you can be half a square out and still get the mark. And you have to get a certain number of points to get full marks. Right, 34 was it? So 40 is the next one. 47. Right, 60, 70, 80, and and then 115. There's 100, 110, 115. All right. So looking at those results, that doesn't look like a straight line to me, but I can check if I put a ruler on there, do those points line up neatly along that line? Not really, do they? And also, I know from my experiment that straight line isn't going to work because this is the shape of the vessel that I was using. All right. So obviously that's not going to be a straight line. So what I need to do is draw a curved line of best fit. Now, most of the time in science, your lines of best fit will be curves. Sometimes they're a straight line, that's fine, that's fairly simple, but most of the time it's going to be a curve. And when I'm drawing a curve, I'm going to do a couple of practice goes just to get used to like the shape of it, because it's not an art lesson. We can't do a sketch, it needs to be one smooth line. Now on this one, I'm not going to go through every single point because it's a line of best fit, right? We're showing the overall pattern. So I'm just going to do my best to do a smooth curve, and I'm going to go fairly faint. I can make it a little bit darker later. It's better to do it in one sweep. I'm not happy with that. I think that should be straighter. And then we should poke off the end either. This is why I use a pencil, so you can correct it if you need to. So I'm just making it a little bit darker. Okay, that'll do. And I'm going to add a label down here. Round bottom flask. You might like to colour code it, but these two lines are far enough apart that I can just write a label and that's fine. And I'm going to give the graph a title, so I'm going to do 500 cubic centimetre measuring cylinder. In an exam, you won't have to give your graph a title. I'm just doing this so I know what it is. So I've got several graphs in my book. And I'm going to date it as well. Always a good idea to date your work, so that you know what goes where in case anything falls out or whatever, or you have to look it up. And that is drawing a graph in science.